Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at an introduction to probability. Now, most sports are based on skill, such as golf and tennis, and even Scrabble would fit into this category. Now, there may be an element of luck in these games, but you still have to have some skill in order to succeed. Other games are based on chance. So contests, lotteries, and games offer the chance of winning a prize. If you've played games like Monopoly or Yahtzee, you notice that games like these involve rolling a dice to try to land on a specific space on the board, or you want to get a certain combination of numbers. So playing card games and board games or tossing coins all involve probability. Now you might ask yourself, does a player have a greater probability of rolling some combinations than others? What's the probability of it will rain or snow or be sunny today? So when a major weather event, like a flood or hurricane, or a massive winter storm affects an area, the news media might state that this is a 1 in 100-year event. Now, probability is also used to make decisions about the world. So in professional baseball, batting averages, pitchers' records, and other statistics are all used to predict the detailed outcomes during a game. Let's begin by looking at some definitions. So if I say some of the words, then you'll know what I'm talking about. So the first definition is the word sample space. So the sample space is the set of all the possible outcomes in a probability experiment. So taking a look at the spinner to the right, if I ask you to list all the possible outcomes of the 5-color spinner, this is called the sample space. So in this example, the sample space would be red, orange, and then we have purple, and yellow, and green. All right, the next thing, or the next word, is event. So an event is one of the possibilities in the sample space. So for example, spinning a red on the spinner. All right, the next definition is called equally likely. So this occurs when each event has an equal chance of happening. So in this spinner, we're going to assume, because it looks the same, that all the colors are the same size. So they are equally likely to occur. All right, now finally we get to the word probability. So probability is a numerical chance that an event will occur. It is always measured on a scale from 0 to 1, or it could be represented as a percent from 0% to 100%. Now, if we say that events are impossible or there's no chance of them occurring, we say they have a probability of 0 or 0%. Events that are certain to occur have a probability of 1 or 100%. Now, when all the outcomes of a sample space, let's call it S, are known, and they're all equally likely, the probability of a single event that we're looking for, let's call it E, is given by the probability formula. So we can say that the probability of the event E, which means the probability of what we're looking for, is equal to the number of outcomes of the event we're looking for, so of E, divided by the number of outcomes of our entire sample space of S. So we can abbreviate this by the number in the event that we're looking for divided by the number in the entire sample space. The last definition is the complement. So the complement is the outcome which is not the event you are looking for. So if the probability of an event happening is the probability of E, the event, then the probability of the event, oh, there's a typo, so let's correct that, not happening is 1 minus the probability of the event happening. Now the reason it's 1 minus is that we know that an event will either occur or not occur. And when we add these two together, we get a probability of 1. So if we go 1 minus the probability of the event occurring, we will get the probability the event does not occur. And there is an abbreviation for this. So we can call this the probability of the event, but then we put a line over the E. So the probability of E with a line over it, this means the probability of event E not occurring. So for example, if the probability that it will snow is 1/8, the probability that it will not snow is equal to 1 minus 1/8. Because either it's going to snow with a probability of 1/8 or it's not going to snow, which is 7/8. Now, we can actually use the complement. It's quite a useful rule for finding probability of at least. So for example, let's say we want at least one boy. At least means we want one boy, 2 boys, 3 boys, 4 boys, and so on. So what we can do is we don't want the probability of 0 boys. So the probability of at least one boy is 1 minus the probability of no boys. So that's how we can use the complement to help us find other probabilities. So note, the sum of the probabilities of all the outcomes in a sample space is 1 or 100%, like I said before, especially with the complement. Either it's going to happen or not going to happen. So when I add these two probabilities together, I should get 1. Another example is when rolling a die, the sum of the probability of each outcome is equal to the probability of 1 or 2 or 3 or 4 or 5 or 6, assuming it's a 6-sided die. So the probability of 1 is 1/6, and we can add all of these together. Plus, so probably getting a 2 is also 1/6. Same with 3, 4, 5, and 6. They're all the same in this example. So we get 6 out of 6, which equals to 1. Now, next we're going to take a look at the different types of probabilities. The first one is called experimental. So, experimental probability is the chance of an event happening based on repeated testing or observations. So, you actually have to do the experiment. So, for example, if I ask you to toss a counter 20 times, and then I ask you to count how many times you get red, you will count how many times you get red and divide that by 20. That would be your sample space. The next one is called theoretical probability. So this is the chance of an event happening as determined by calculating the mathematical results. So for the same example, when you toss a counter 20 times, mathematically, you should get red 10 times, assuming the counter has red on one side and a different color on the other side. So the theoretical probability of getting red is 10, that's the event that we're looking for, divided by the sample space of 20, which equals to a half. The last type of probability is subjective probability. So this is the chance an event will happen based on a person's belief in the event. It is based on educated guesses, estimates, subjective judgments, experience, information, and beliefs. So it contains a high degree of personal bias and it's not very mathematical. So example, if a person always tosses red, he may say that the probability the next toss is red is going to be 0. Since it's always been red, then probably the next toss won't be red, so probability of 0. Or we can say the probability the next toss is red is going to be 1, only because it's always red. So it is very subjective, and probabilities can range from anywhere from 0 to 1. All right, and that is a brief introduction to probability.